This is the CrossOrigin resource sharing. My name is Garey Hoffman. I'm going to give you an introduction to what this is, and how to use it, and why it matters. As much as I'd like to get into a lot of the internals, today is mostly going to focus on a lot of the building blocks that you can then use to go navigate these waters yourself. So let's go ahead and get started. What is CORS? Well, here's a definition straight out of the specification site. CrossOrigin resource sharing is a mechanism that relaxes the built-in restrictions of a web browser. That matters. And that matters for a variety of reasons, and we'll get further into it. Certain cross-domain requests, notably Ajax requests, however, are forbidden by default by the same origin security policy. Okay, all right, it's a little different. So what does that really mean to us? Well, what is no restrictions? No problem. Well, by default, a web page may freely embed images, style sheets, iframes, videos. We do that all the time, right? Well, yeah, we do. No big deal. But CORS allows restricted resources on a web page. Okay, so what are those? Let's find out. These are restricted resources. Your Ajax requests or XML HTTP requests, sometimes we just call it XHR, fetch APIs, web fonts, GL textures. Now, some of these things we don't really use on a daily basis, but of course we know what Ajax is. What else? Images or video frames drawn to a canvas, CSS object model, and scripts for unmuted exceptions, which is an unusual topic. We're going to kind of avoid that for now. But in terms of being complete, there it is. These are restricted resources. Yep, I want to use restricted resources. Usually for most of us, that means Ajax, right? XML HTTP request. OK, but CORS allows restricted resources. That's the whole point. OK, well, did I go the wrong direction? I did. So what exactly is CrossOrigin? Well, before we go into CrossOrigin, let's talk about same origin, because it's amazing how oftentimes that gets confused. Let's just start there. Same origin. Under the same origin policy, a web browser permits scripts contained in a first web page to access data in a second, but only if web pages have the same origin. All right, there's our little graphic. It shows us what that means. Domain A, web page A, web page B, go to the web browser. Everybody's happy, thumbs up. So let's talk about that a little further. So the same origin policy basically says, well, if domain and domain B are two different locations, we'll find out more about what that means. Well, that's a restricted access. That's a restricted resource. No, it's not allowed. Well, unless you have CORS. That's why we're here. That's what this whole point is. OK, now we're back to the idea of what is CrossOrigin. Again, this matters. And this is part of what you're going to need to actually implement CORS without, one, opening up a security hole, two, it actually works and you're not pulling your hair out. So CrossOrigin resource sharing is a technique for relaxing, again, the same origin policy. That's it. And in this case, we generally want to use it for JavaScript on a web page to be able to serve up like a REST API. OK, well, it makes CORS work. Well, CORS does make it work. In this case, here's my little graphic here saying, you know, you add the CORS to this whole process, and that's what you get. You actually get the ability to look at that restricted resource or use that restricted resource. And again, we'll get further into it. It's OK, so what exactly does that mean? What is same origin? Well, for our purposes, it's same URL. A URL consists of 3 elements, right? Let's talk about what those 3 elements are. A scheme, protocol, a host name, and a port number. Whether it's a default port number or it's a port number you actually specifically specify or identify. So here's a little handy little reference chart to help you figure out, well, what exactly is same origin and what's not. You can see in this example here, so if I have an origin of www.ociweb.com/index.html, that's my origin. So if I go to another location in that same scheme, domain, well, I do have a different directory structure, but I'm assuming it's, I'm not identifying the ports. I'm assuming it's default port. So that's success. That works. OK, here's another example of that. Same idea, scheme, you know, the protocol, and we got our domain. And again, it's a different directory structure, but that's fine. Now, this is where it's interesting, is again, where are failures? This next line here has a different scheme, all right? An SSL-enabled HTTP protocol. So it fails. That's different. This is where things like CORS come into play, because that's now a restricted resource. You have to actually consider this when you're accessing certain types of objects from other sources. Recall, again, early slides, we talked about restricted resources. Some things just work, like images. But this case, there are certain kinds of things that don't. Generally, for our purposes, those are Ajax requests and things like that, a REST API. So let's take a look at the next one. Here, we're actually defining a separate port. In this case, we made our own port, port 81. That's going to fail. It's a different port that differs from our origin. Lastly, we've got a whole different domain, partnercompany.com. I just made it up. So again, that differs, so it's going to fail because it's a different host. So how do I use CORS? Well, first off, we need to figure out there are actually more than one type of CORS implementation. There's something called simple requests and something called pre-flight requests. We'll get further into each of these at this point. And let's go ahead and talk about the simple requests. Simple requests are a GET, and then or a head request, or certain types of posts. And importantly, what matters here, you're not submitting a payload. All right? So you can make a post request that's empty, and without using CORS, it'll probably work fine. Now, there's something called a pre-flight request for certain types of CORS requests. And that's interesting because it actually causes multiple queries to the remote host. You actually query it and get a response back, and then you send your actual request and payload. It's 2 steps. So it's a pre-flight. We're going to get more into what that actually means. Now, you might be wondering, well, why do I want to do that? Well, the idea behind CORS is to allow you to relax or ask the browser to relax its restrictions in a way that you, as the host owner, are comfortable with. Now, if somebody has, let's say, an evil browser, a hacked browser, well, it doesn't really work because the assumption is that the browser is operating in good faith. So keep that in mind. Let's go back to the simple requests. OK, here's just a simple example. I'm making a request to a remote resource. You can see an example. I've stripped out everything except what's important for the actual HTTP request. There's a response. Get that back. All right? Sounds great. When I'm making on that particular page, let's say that there's an additional call to an Ajax resource that's, OK, if you look here, it's a different origin. API.OCI web rather than www.OCI web. So that's different. That's not the same. They are treated the same. You know, that we oftentimes think as a primary domain, OCIweb.com, for example, as, well, everything under that, it's all safe, it's all good. That's not the case when it comes to CrossOrigin or the same origin policy. It's very restrictive, and that's intentional. So you do have some control. So let's say, again, on this page, you have this request taking place. You have your Ajax request now occurring. And again, I've stripped out everything except what matters here, which is you've got the host, the origin that's being written by the browser as part of the request to the remote server. What comes back? Well, the access control, allow origin, this is part of the header. That's part of the CORS spec right there. We'll decompose this more. We'll see more of this. But this is a first example of a simple request and what it looks like. And you notice, again, in this case, we've got an application/JSON content type because that meets our criteria of a restricted resource. This is why we have to do it. So there it is. This is the simplest example of a CORS request response structure. So let's go back to this concept of a pre-flight request. This page is going to get a bit messy. I'll just tell you right now, because you're going to see multiple requests occur for something to be returned. So again, we're going to make a request. We're going to ask for a response. We get it. HTTP 200. And here you see I get an Ajax thing that I want that's in that first request that, oh, I want to go make a request to that object that's out there. Look at that. My request out to the remote host, in this case api.ociweb.com, has a different type. It's options. This is where you're asking the remote resource, hey, here's who I am. Here's my origin. Here's my access control method. In this case, I'm making a post. Again, these are more of the CORS header specification that we'll learn more about. And here's other pieces of the puzzle, the access control request headers, authorization and content type. And again, I've stripped out things that don't matter at this point. So what comes back? Okay, it says, hey, okay, all right, I get your origin. Your origin's good. In this case, again, that comes back. It's the same exact one. And here's the allowed methods, post, get, and options. Here's my allowed headers. And you notice these match. This actually is part of some things that can cause grief is authorization and content type. You put only the ones you need. And again, this is, again, you only open up, relax the browser restrictions as much as necessary and no more. Okay, now I'm actually, my client, I'm actually going to make my actual post, the real thing. I'm going to send my data. Now that I know who you are, you agreeing, and we're both agreeing that this is an approved sending of this payload, I'm going to go ahead and send it. Here's my post, and I'm going to send it with my payload. And as you can see here, sometimes you may have an authorization header if that's important. It may or may not be if it's an authorized interface. Your content type, and again, you're showing your origin. And then your response. And again, this, like I said, this page gets a bit messy, but here you go. He goes, great, I got it. Thanks very much. Now, a couple little details that I don't have elsewhere on other slides that are important. Is anyone familiar with the HTTP 204 no content type that's out there? So for those that don't know, there was a period, there's been discussions in recent years of adjusting the CORS specification such that as a good practice, the first part of, the first part of this whole request response process where the options are sent, the response is specifically supposed to be a 204. That has not been a debate that's been settled. So most browser vendors are allowing anything in the 200 space, okay? So if you see 204, that's what that is. People thinking that, well, this is good practice. This is probably long-term more viable. I'm not going to have to worry about changes in specification. That, I don't know if or when that's ever going to change, but just be aware that 200, for the most part, is pretty reasonable for most major browsers out there. So that's, even though the 204 is something that has been discussed, but I don't see that changing anytime soon. So what browsers support CORS? You got Chrome, of course, Firefox 3.5. And I can't remember again, that's much earlier. That's much prior to the recent renaming of the Firefox versioning system where they're now on to what, Firefox 55 or something like that. It's pretty old. So I don't know what, I can't remember the latest Firefox version number. But Firefox 3.5 is pretty old. And you got Opera and you got Safari. And probably the one that causes the most grief is you got Internet Explorer. So just be aware, it does go back pretty far in terms of CORS support. They're not perfect. And as you might imagine, Internet Explorer is probably the sketchiest of the group, but there is reasonable support that goes back a number of years. So let's talk about some of these tips. And again, these are supposed to be items in a header. And one of the things that you find if you go poke around online looking for any kind of assistance or resources on this topic is people will say, cool, there's a wildcard, and that'll make it work. Sadly, we all know that things like that frequently end up in production. And unfortunately, it's not something you're supposed to do. you're opening yourself up to, or your customer to a potential attack vector. So as a general rule, unless you're absolutely certain it's not going to end up in a production-like scenario, don't do it. Unless, of course, you're Google or your Amazon, or you're trying to create an open API where that is okay, where you do want to allow any origin to pass in and retrieve materials. So if you go look at Amazon's published REST APIs, or Google's, or any other major provider, they've implemented this, and they really do use a star for their origin. They really do. So that's actually a very interesting thought experiment to go conduct, is to go find an open API and see how they've implemented it. And some of them simply echo back whatever the origin in the browser says. I've seen that as well. And that's their way of being what they call are future-proofing the scenario. So you may see that, and that's considered acceptable in my opinion. But again, unless you're doing an open or public API, don't use the wildcard. We'll talk more about the wildcard. That's the same slide there. Don't use partial values. So here's an example. This doesn't work. star.domain.com, OCIweb.com, it does not work. So it may seem obvious to us when we're, as developers, developing patterns, it doesn't work. So it's not part of the core specification. And again, you'll find people online, if you go search on Stack Overflow, I tried this and it worked. Well, no, it actually didn't work. So, something else was broken or not part of your implementation. Your DNS is broken. That's a great example. Also, something I don't have a slide on, and this is probably a good time to talk about that. You add the same header multiple times, you're going to get unexpected behavior. So don't do it. So, so be aware of that. If you add this multiple times, different browsers react differently. Some of them just say, well, I'm going to assume it's not there at all. That's actually how some browsers operate, which is I don't know which one's the correct or valid one, so I'm just going to assume it's not there. So just be aware of that. Don't forget to include the scheme or the protocol in your definition. If you put just www.ociweb.com, it'll break. The only thing that's actually optional is the port, and we'll talk more about that. You have to put the actual scheme or protocol. Here's the port. Here's the port. So as you might imagine, it makes sense that if it's a default port, port 80, port 443, you don't have to specify, because we don't do that anyway. But if you do have a specific port that's not the default port, you have to include it. So just be aware. So your browser, when it sends up the origin as part of the request before the response comes back, if it is not a default origin and port, sorry, a port as part of that origin, it will actually include it for you. I have yet to see where that's broken. I've seen a lot of major implementations, and that's generally not broken. So just be aware that your browser will do that for you if it's a non-standard port. Don't use partial wildcard. I gotta remember which one this one is. So this is a compound don't tip. So if you set your origin to star, or sorry, I take that back. If you set your allowed credentials to true, and we'll talk more about credentials in a minute, that's actually when it sends cookies. Because generally, as a default, unless you include that particular line item in your header, you won't send cookies. And that's actually a good thing, because it actually prevents cross forgery attacks. So unless you have mitigated that through other cross-site request forgery mitigation scenarios, don't do it. But if you do set it to true, meaning cookies are going to be sent as part of your header payload, it will not work with star. And again, I think this is me just speculating here, but I think this is done by browser vendors to prevent people from completely opening themselves to potential attack vectors. And there must have been a decision early on during the specification creation where they did that. So that's just speculation on my part, but it seems kind of clear from my perspective. So just be aware that if you try to create a proof of concept, you're trying to get cookies to work, because they're important for whether it's some kind of session management or authorization or whatever, and you're using star origin in your proof of concept, it's not going to work. So I've personally been burned by this one. So that's why I put it up here. So let's talk about this credentials thing again. Don't use it unless it's necessary. And again, I mentioned that previously. And it can open you up to an attack vector if you have not properly mitigated your request forgery scenarios. So, and cross-site request forgery obviously is a whole other topic on its own. And just don't return multiple domains for access, control, allow, origin. All right, here's some examples. Actually, it's the same example. I meant to actually have one example that had with a comma and the other one with a space, but that was the point. So this will not work. And don't try to duplicate the line over and over again. That won't work either. So don't do it. So the specification is meant to be restrictive because they want developers to be very deliberate in what they do rather than provide you a convenient umbrella just to make it work. It's meant to relax the restrictions built into the browser. So by doing so, they're saying, OK, if you're going to do it, make sure you're very deliberate and only open as much as you need and no more. So just be aware of that. And again, these are pitfalls that I've personally been burned on, and I'm sure others that have done CORS implementations probably have as well. Try to implement CORS near the edge of your delivery architecture. Now, this is something that we'll talk about. So this is, again, a guideline, because clearly you can't always do it. So let's talk about what that means. I've seen implementations where sometimes, again, there's the pragmatic aspect of it in your middle tier that where you have most of your logic being handled. And I've seen attempts to try to manage CORS or inject CORS headers at that point. Well, the problem is that let's say you have certain types of load balancing implementations that strip out origin or rewrite it. It can cause problems. So just be aware that what you develop, let's say in a very simple proof of concept architecture, you need to consider your final deployment architecture in this. Because let's say you have like a data power appliance, an XML security gateway, it can wreak havoc out of the box on your headers because that's what it's designed to do. It's designed to be restrictive on purpose unless you open it up. So be aware that's the case. So as a general rule, I ask folks to try to implement near the edge of their delivery architecture because it will dramatically simplify your implementation. And with a lot of thought at a time in your architecture design, you should be able to maintain it. We'll talk more about that a little bit. So here's another scenario, which is don't inject CORS headers in multiple locations. Don't do that either. I've seen that happen. And that usually happens when people are using the shotgun approach to try to fix something. It's not working. Well, I tried to put it here, it didn't work. I tried to put it there. Well, did it work? Well, it works. Hey, great. This is not maintainable for obvious reasons. I think we, as engineers, get that. So it's difficult to debug. It's brittle. It'll make you crazy. So I've seen this. I've intentionally ripped this out of more than one installation I've seen. So just be aware that does happen. I've intentionally not really talked about what exactly edge of your delivery architecture means, because that's going to be very specific to everybody's implementation. It's a guideline that I'm asking you to consider when you're putting together a solution. Consider alternate ways to circumvent CORS where appropriate. I think that's a viable scenario. You can do it. And in fact, some of these make a lot of sense. So let's talk about what those are. So a reverse proxy. It's the simplest one, the easiest one to implement. And if you do your own rewriting, you can do it very safely, and you can actually create a sustainable product. So that's something to consider. JSONP, something I'm not incredibly familiar with, but I know that as a communication method for payloads, it will work. Actually, the way it's built, it will circumvent CORS. So I listed it here for completeness sake. So let's talk about an HTML iframe. Again, depending upon your implementation, that might be viable. That will circumvent. And then, of course, to some degree, document the domain and rewriting the origin, that's what that's supposed to get to, and post message. These do have small abilities to circumvent parts of the CORS framework. Not all of it, but parts of it. That's a good and a bad thing. Just be aware of it. So I've heard of scenarios where that has been an attack vector. I've heard of it. I don't personally have seen it, but so there's considerations to keep in mind there. So what did we cover? We talked about the same origin policy. What exactly is it? What does CrossOrigin actually mean? What is CORS? Well, we got simple, and then we got the pre-flight. And we talked about the browsers that support CORS, and I've given you my version of tips and pitfalls to avoid, and hopefully a few reasonable practices. Now, that pretty much brings us to the end. I had hoped to have a few more slides on some interesting implementations using some different application servers, but I don't have those right now, so I'd love to take questions.
So are you
Jason.
suggesting to implement JSON-P endpoints instead of putting a CORS configuration?
I'm saying it's on the table. So let me repeat for those that may be listening online. The question is, am I suggesting that JSON-P be used as an alternate to CORS implementations? I'm saying it's an option from my perspective. It is on the table as a consideration. I'm not saying it is a preferred practice by any means. So
you would be opening yourself up. That's the equivalent.
I agree.
It
is, but I have seen scenarios where you have broken third-party vendors, and that's your only option.
But then they would have to implement it.
Yes. Yes, that's exactly, yes. So third-party vendors I've seen had to do it so that you have an ability to operate. I've seen that happen. So I don't see that as a good practice. And the reason I'm throwing it up there so that if you run across it, you're not going, what the heck is this? Why is this here? It's broken, in my opinion. It defeats the purpose. But it's there. I threw it on the board so that you guys will have some awareness if you run across it. Obviously, you get it. You get the point. So next.
I actually just kind of wanted to share
a
little bit of what I've done. Got bit a little bit.
By some of these? You got bit by some of these problems?
So not quite. So I've got an acceptable Spring application.
Okay.
As a controller, I leverage CrossOrigin and specify the origin. Right? So I'm very explicit about white listing it appropriately.
So using Spring, you actually were explicit in the origin rather than using any kind of passive approach.
Correct.
Okay.
Correct. So it only comes from my partner to my client to the back.
Mm-hmm.
That's for REST and for Ajax. Well, they added a new origin. So that was telling me that I'm standing up in the environment. Boom, it broke 403s all over the environment. I think those are forbidden. So that's the only pitfall I see, because then you got to go back, you got to recompile, like redeploy. So there's not a good way with that implementation to do it with any sort of dynamicism to add origins on the fly. So
I'll repeat as much as I can. Keep me honest and make sure I get it correct for those that may be either streaming or listening online. And for posterity's sake, is that your experience is that, yes, it's great to be able to specify, and you have specified the domains in the origin, but when a customer implements or adds additional domains, that is a difficult, or you've been bit by the maintainability of that. So that itself is an interesting problem there. That should be considered as part of any kind of sustainment effort, that not only awareness when that occurs, but hopefully you can build in the ability to make that reasonably sustainable. That's interesting. That's a good point. So,
well, but in a way, to carry on from that point, that should be part of the contract with that partner, is that these are the domains that are allowed. If you add another domain, we need to negotiate that to see, is that legitimate, is that allowed? And so you're,
I like that. If you include that in the, as part of, let's say, the criteria or a checklist of saying, here's what we're going to implement as developers, as a solution provider. If you need to do more, be aware there may be additional effort to make this work. It's not just going to turn on. This is a security mechanism. It should be treated as such. It's not something that it's not laissez-faire. It needs to be analyzed. And if you need the ability, like we know of certain customers that add new domains as they add their own customers all the time, if you need the ability to have a much more automated mechanism, well, that needs to be part of the design requirement.
That's what I'm saying.
Yeah.
Make it deliberate.
Make it deliberate. I like that.
So
Yeah.
this is a negotiation between the server and the browser.
That's it.
And the question is, how much do I have to trust the browser? If I have the most nefarious browser out there, how much could it possibly get away with?
So the assumption of the entire framework is genuine and good guy browsers. You're absolutely right. When you're dealing with nefarious activity, whether it's known by the actual user of the browser, or it's an actual nefarious attacker being deliberate, this isn't going to work. This whole relationship of trust is built on the browser and the server assuming each is genuine. So this is why this is why you have to be careful about dealing with things like the cross-site request forgery, which is generally, we know it as like a phishing attack is most common, because if you wade into those territories, you could open yourself up to those kinds of problems. So
if I could lie to the server, tell it whatever I want,
yeah.
and then I can go wherever I want.
You're right. So this has to be part of an overall security model. It's not just, oh, I have that, so I need to go relax the browser so I can I need to do A so I can do B. You need to be careful so that you need to make sure that you're not opening up other scenarios. And that's something I've seen debates about going, well, why does this exist at all? Well, it's because of the original idea of the same origin policy, which is I'm here to actually, as a good guy browser, to do what I can to provide you functionality within some kind of reasonable sandbox. But there are scenarios we know that provide additional functionality by being able to integrate with third-party locations. So how do you walk that very fine line? And I think this is what those that have written the specifications and provided and built the products have decided, well, this is the least bad solution. So I've always been fascinated by this topic because it is strange. It's definitely different than previous security models, which is never trust, always verify. To steal from Colin Powell. So it's very different from that. So any other questions? I had hoped to provide you example implementations in Nginx and Apache Tomcat and Apache Web Server. Fortunately, a lot of that stuff's online, but and even examples in, let's say, like Spring Boot, where you can see how the differences between a container implementation versus a code implementation, although they have a lot of commonality, they are interesting to look at. Unfortunately, I didn't get all that put together, so my apology on that. So anything else? Otherwise, that concludes this.